Hello and welcome to my YouTube channel. If you are watching my video for the first time, please consider subscribing to the channel. I've planned to create more such videos on cloud, DevOps and microservices in the near future. In today's video, we are going to deploy a 3-tier web application on AWS. So let's start the video. Before we can actually begin deploying the application components, we will need to create the networking base for the same. In this use case, we will create a VPC, 3 public subnets, that is 1 subnet in each availability zone. These subnet will have our internet facing load balancers, web servers and jump servers. We will then create a private app subnet in each availability zone for application deployment, and finally we will create private subnets for DB instances. Once the VPC and subnets are done, we will require gateways to configure incoming and outgoing traffic. Firstly, internet gateway needs to be configured with the VPC, and then a NAT gateway needs to be created in any of the public subnets. As a best practice, it is recommended to create multiple NAT gateways for redundancy, but for this demo, we will stick with a single NAT gateway. People often make the mistake of creating the NAT gateway in the private subnet. Although the NAT gateway is used to facilitate outgoing internet traffic for private subnets, it needs to reside in the public subnet. After the gateways are created, we will need to create the corresponding route tables for web, app and DB subnets. Once the underlying networking infrastructure to host a 3-tier application is created, we can start with the application components. For this use case, Route 53 is optional as we can directly access the application via application load balancer. Then we will create 2 EC2 instances on both availability zones and install PHP and Apache on it. And finally, we will create the RDS instances. Here the multi-AZ configuration is optional. Now let's quickly jump into the actual implementation. Under services section, let's go to VPC. Click on VPCs. Click on the VPC ID. You will notice that the default VPC is yes. So we are not going to use that VPC. Instead, we will create our own VPC. So we will name the VPC as my VPC. The CIDR would be 172.20.0.0/20. We will keep the VPv6 CIDR block as is. We'll keep the tenancy as default. Then we'll hit the create VPC button. We will quickly verify whether the VPC is created as expected. Then we will move on to the subnets. Okay, so here also we will notice that the subnets are already created, but we will not use that as the subnets are the default ones. So we will start the subnet creation. So we'll give the name my public web subnet 1. Select the availability zone as US East 2A. Put the VP4 CIDR block as 172.20.1.0/24. Keep the tags as is. Let's create the second subnet. Put the name as my public web subnet 2. Availability zone as US East 2B. CIDR block as 172.2.0/24. Now let's create the third public subnet. We'll keep the same naming convention. My public web subnet 3. CIDR block as 172.20.3.0/24. We'll select the availability zone as 2C. We'll quickly verify whether the subnets are as expected. Once that is done, we'll move to creation of app subnets. So our naming convention would be my private app subnet 1. The availability zone would be US East 2A. CIDR range would be 172.24.0/24. Similarly, create the second subnet, my private app subnet 2. Availability zone as 2B. CIDR range as 172.25.0/24. Now let's create the third one, my private app subnet 3. availability zone as 2C, CIDR block as 172.26.0/24. Now let's move to the last tier, that is the DB tier. Let's put the naming convention as my private DB subnet 1. We'll select the availability zone as 2A. The CIDR range would be 172.27.0/24. Let's create the second DB subnet, my private DB subnet 2. Let's select the availability zone as 2B. The CIDR range would be 172.28.0/24. Now let's create the last subnet, my private DB subnet 3. Availability zone as 2C. CIDR range as 172.29.0/24. Now quickly verify whether all the subnets are created as expected. Once verified, now let's click the create subnet button. Now the subnet creation is in progress. Now quickly verify whether all the subnets are created. Okay, so once the subnets are created, let's move to the creation of route tables. So the first route table would be my public route table. We will select the VPC that we created and click on the create route table button. Now let's create the route table for app player. My private app route table. Select the VPC that we created. Click on the create route table button. And finally, we will create the route table for DB. So the naming convention would be my private DB route table. So quickly verify whether the route tables are created. So once the route tables are created, we need to associate the route tables with the appropriate subnets. Okay, so we have selected the web route table. Let's associate the route tables with subnets, the web subnets. Let's do the same for app route table as well. And finally, the DB route table. Once the route tables are created, we need to establish the connectivity. For that, we will require internet gateway for public web subnet. Let's name the internet gateway as my internet gateway and click on the create internet gateway button. Once the internet gateway is created, we have to also attach to the VPC. So let's do that. Okay. Once the internet gateway is created, we have to move to NAT gateways. Let's create the NAT gateway. Give the name as my NAT gateway. Select the public subnet 1. For this demo, we are going to create the NAT gateway in only one subnet, but as a best practice, you should create multiple NAT gateways to ensure redundancy. Also allocate the elastic IP to the NAT gateway and let's create the NAT gateway. So this will take some time. So our NAT gateway is created. So once the internet gateway and the NAT gateway is created, we have to make changes in the route tables so that the connectivity to the internet will be established from your internet gateway for the public subnets and NAT gateway for the private subnets. So we will add a route in the public route table for 0.0.0/0 and we'll point it to internet gateway. Similarly, we will make changes to the app route table. We will create a route for app route table. We will add 0.0.0.0/0 for NAT gateway. And then finally, we will do the same for DB subnet as well, or the DB route table as well. So we'll add the same entry 0.0.0.0/0 and point it to NAT gateway. So this completes our networking configuration. So we have created VPCs, route tables, subnets, internet gateway, NAT gateway. We have associated them. Now let's start deploying the application components. So we'll go to EC2 instance. Click on the instances. Click on the launch instances. We'll select the Amazon Linux 2 AMI. We will select T2 micro. We will select the VPC that we created. We will select the public subnet because this would be our jump server. Select the enable for auto assign IP. Storage we can keep as is. Tags we can add a name tag. We can give the name as my jump server. We'll create a new security group. We'll keep the same naming convention, my jump server SG. Now let's click on launch, create a new key pair, my key pair.pem. Click on launch instances. Please ensure that you have downloaded the PEM key. Now let's create the PHP instances. Select the Amazon Linux 2 AMI. Keep the instance type as T2 micro. Select the VPC that we created. Select the app subnet. We can keep the storage as it is. Now let's add the tag name, my PHP app server 1. We'll create a new security group for the app layer. So give the name as my PHP app server SG. We will allow the SSH connection for this app server only from the jump server. So let's remove the entry and put the my jump server SG. Click on launch. We already have the key pair. Click on launch instances. This will take some time. Meanwhile, the instance is creating. We will create the other PHP server. So we will follow the similar configuration. We'll select the AMI as Amazon Linux. We'll select the instance type as T2 micro. We'll select the VPC that we created. We will select the other app subnet. We'll keep the storage as it is. We'll add the tag name, my PHP app server 2. The security group is already created. We will select that security group. The key is already there, so we will acknowledge and launch the instances. So all of the servers are in running state. Now let's try to connect to the jump server from our local machine. You can get the connectivity details from the connect button. We have already downloaded the key pair. We will give the appropriate permissions to that key pair, and let's try to connect to the server. So we have logged into the jump server. Now let's try to copy our SSH key. Give the appropriate permission to the SSH key. Now we have to connect to the PHP app server. Click on the PHP app server 1. Click on the connect button. We will get the example connectivity. Paste that in the jump server. Now we are logged into our app server. Now we have to install PHP and Apache on that app server. So let's follow the documentation from AWS. I will provide the link to the documentation in the description. So let's follow all the steps on the app server. So we'll do a yum update. Then we'll install the required packages. Now install our Apache server. We do not require MariaDB because we are going to use the RDS instance. So our Apache is installed. We'll start the Apache server. Now we will enable the Apache service. We'll verify whether the Apache service is created. Now let's check whether the HTTPD service is enabled and it is working. So yeah, it works. Now let's give appropriate permission to our EC2 user. Change the ownership of our www folder. So as a sample application, we will install phpMyAdmin. So we'll follow all the steps required to install phpMyAdmin. So we are restarting the Apache service. We are restarting the PHP FPM service. Now let's navigate to HTML folder. Download the phpMyAdmin package. So once the packages are downloaded, we will create a directory for phpMyAdmin and we will untar that files. And we will remove the phpMyAdmin tar file. So for now we are done with the configuration of phpMyAdmin. At a later stage when RDS is created, we will make certain changes to the config file. So once the app instances are created, we will move towards creation of load balancer. So let's create load balancer, select application load balancer, give the name as my ALB. Scheme should be internet facing because we want to expose the load balancer to the outside world. Select the VPC, select the availability zones as public subnets. Now go to the security group settings. Create a new security group. Give the name as my ALBSG. Source 0000 is fine. Create a new target group. Give the name as my ALB PHP TG. Target type is instances. Let's keep the port as 80. Now register the targets. We have already created the PHP servers. Now let's select those and click add to register button. Now create the ALB. So we have now successfully created the load balancer. Now check the target group. Let's see whether the instances are in the healthy state. Right now they are in the initial state as the target registration is in process. By the time our instances are getting registered in the target group, we need to allow the load balancer security group in our app server security group. So let's make that changes. Click on edit inbound rules, add a rule, select port 80 and select the security group of ALB. So this will establish connectivity between your ALB and the instances. So now let's go to load balancer section and copy the DNS name. Paste the DNS name in the browser and let's see whether the test page is appearing. Yeah, it does. Now we are able to see the Apache test page. Now we have to check whether the load balancing is happening as expected. So we have to create an index.html file in the var www html folder in both the PHP app servers to validate whether the requests are going to both the app servers. We will put a sample text in the index.html page as PHP server 1 and PHP server 2. Once the files are saved in both the servers, we will navigate to index.html on the web browser to check whether the requests are flowing to both the app servers. So we can see on the screen that it is going to PHP server 1 and PHP server 2. So now we have created two layers of the three-tier architecture, the web layer and app layer. Now let's move to the third layer, that is the DB layer. Now let's navigate to RDS. Click on the subnet groups. As we have created separate subnets for DB instances, give the name as my DB subnet group. We can copy the same and put it in the description. Choose the VPC that we have created. Choose the availability zones 2A and 2B. We have to select the subnets that were created for DB and click on create. So once our subnet groups are created, we will move to creation of the actual DB instance. So let's create database. Select standard create, MySQL. Click the free tier. Give the instance name as MyDB. We'll keep the master username as is. Let's put the password. Confirm the password. Keep the instance class as T2 micro. Disable the storage auto scaling. In connectivity, we will select the VPC that we created. The DB subnet group is selected by default. We will create a new security group name, that is MyDBSG, and we will create the database. Once our database is created, we will need to enable the connectivity between your app server and the DB server. So we have to go to the security group of the DB. And we have to add one entry for the PHP app servers. So in the inbound rules, we will add a rule for 3306. And in the source, we will put the app server security group and we will delete the default rule that was created. And let's save the rules. The creating will take some time. So by the time it is in backup stage, let's copy the endpoint. We will go to the PHP server. We will navigate to the phpMyAdmin folder. Under the phpMyAdmin folder, we will rename the file config.map.inc.php to config.inc.php. Now let's open that file. Search the host. Search for host. Replace localhost with the copied host name of the RDS instance that we just created. Save the file and on the browser navigate to phpMyAdmin and check whether the application is running or not. Now once you punch in your credentials, you'll see the error failed to set session cookie. This happens because phpMyAdmin is a stateful application. The session is stored on individual servers. Since the load balancing is configured as round robin, requests are going to both the servers. As a workaround, what we can do is go to target groups, select our target group, go to the attribute tab and enable session stickiness with the load balancer generated cookie. This way, your request will flow to only one server and in case of a failure, it will be redirected to the other server. Once the changes are made, we can open the incognito mode of the browser and check the phpMyAdmin. Now you will be able to log into the application. Now let's do a quick recap of all the resources we created. First of all, we created the VPC, then the corresponding subnets, then the route tables, then the internet gateway and attached it to the VPC. Then we created the NAT gateway in the public subnet. Then we created the jump server and the PHP app servers. Then we moved on to the load balancer. We created a target group and a load balancer. And finally, we created the RDS instance. Thanks for watching. If you like this video, please hit the like button and subscribe to my channel.